What's up, Covalence friends? Today, we're going to be dealing with more WebSockets. We've already set up our basic WebSocket server. We've handled creating heartbeats for not keeping around dead WebSocket connections. We've gone through WebSocket authentication and authorization. And today, we're going through our final phase of our little WebSocket series, which is routing our WebSockets. I'm not going to go into any more. Let's just get right into it. All right, so we're actually starting where we left off with our WebSocket authentication and authorization. If you haven't watched that video, I put the link in the description below, so I highly encourage that you actually watch that first. But basically, we already have a WebSocket template here. It's a WebSocket server template that has heartbeats initiated, and we actually have a cookie and token authorization / authentication strategy going on. So it handles both methods. And we're going to kind of use the token strategy here to showcase this whole idea of separating out our WebSocket rooms per se, or WebSocket connections for a particular thread ID. So we're basically in the context of a chat application that has multiple threads or multiple rooms. We want to make sure that if somebody sends a message in a particular thread, only the people in that thread are going to get the message, right? So where we want to start is we're actually open up our sockets folder and we're going to index.ts, and we're basically going to create a new object here that's going to act as essentially a hash map, but we're going to call it clients, and it's going to be a JavaScript object, and we're going to have essentially another object called threads in here. Now, if you had more than just threads in your application, like for instance, if you had something like scoring, if you had like a game that was going to do real-time scoring that you wanted all of the people currently connected to currently see, like a leaderboard type thing, you might have something like scoring as well. But in our particular case, we're just going to have only threads for now. And we actually probably should define some sort of interface for this. So let's go ahead and we're going to open up our typings and we're going to go to ws.d.ts. And since we're going to be using the WebSocket from here, right, we're going to populate this object with arrays of WebSockets from our WS package, then we want to do it kind of in our ws.d.ts here. So we're going to define a new interface. I'm going to just call it WebSocket clients. And that's going to have threads in it, right? And this is actually going to be, we're going to say that it's just string-based indexing, and it's going to be a WebSocket array. All right, so this is going to be WebSocket clients. If you had scoring as well, you would also include scoring here, and it would be basically the exact same thing. You could break this out into a separate interface as well if you're going to have more than one, and you'd be able to just kind of populate all of this with whatever this particular thing is, right? An socket array kind of thing, right? So we're going to go back to our index.ts and we're just going to say as WebSocket clients, and you can see that it imports now from our WS module, which is nice, right? So we have our clients and we're going to now have to use those clients, right? We're going to have to populate that client array. So if we go down to our configure section here, this is kind of where we're handling all the authorization or the authentication. And we're using our request.url. Now, this is obviously everything after the host name. So if we're on localhost 3000 /thread/thread ID, and then any kind of query parameters after that, request.url is basically going to be everything after the localhost 3000 part, right? So everything from the first part of the path all the way through the query parameters. And so we're going to want to handle that logic actually down here in the connection, right? So basically, we're going to finally get to use this request variable here that wasn't being used, and now it's going to be. But more or less what we want to be doing is we want to kind of be handling these message, like the message and the close connections. Now, you could actually do it with error too, but for our particular case, we're only going to deal with message and close. But we're going to kind of break this out, and we're going to kind of define these events differently depending on whether or not we're sending to everyone or we're sending to just a particular room, right? Or a particular thread in our case. So what we really want to do is we want to kind of create two new functions for now, right? We're going to have send all, and we're going to take in our WebSocket, and we're going to take in our WebSocket server. And then we're going to have another function called sendThread, and we're going to take in our WebSocket again, and we're also going to take in our thread ID. All right, and so the send all is basically going to be, like I said, we're going to handle the close and message events here. So let's go ahead and just pull those out, and we're going to pass them into this function now. So this is going to handle basically hooking up our message and our close event handlers. Now you could do it with error too, but we're not going to worry about that since we're just logging the error no matter what for now. But we want to handle these cases differently depending on the close and the message part of it, right? So for now, actually, I really hate this. So while we have our wsid.ts open, let's go ahead and kind of fix that real quick. So what we want to do is we can just define an additional type. So let's see, IEXT raw data, let's just say. And that's going to equal, we need to import raw data first. So we're going to import raw data. That's going to equal raw data, and let's just say, number array here. All right, so we have this new type that is going to be IEXT raw data. And you can see that it imported it, from the WS module. And now we shouldn't have to do this anymore. And actually what we can do is we can actually also check message.length equals 1. And now we can actually handle binary data that isn't just our heartbeat, right? So our heartbeat is literally just a single byte of 1, right? And so we wanted to make sure that if message.length equals 1, otherwise we may actually be sending some sort of blob or binary data, right? So again, this is just making it a little bit more correct. This should probably be fixed in the actual WebSocket template as well. But again, for right now, don't worry about it too much. But this is basically all we need for the send all, but we're actually going to have similar logic in our send thread, right? So we're not obviously going to be doing anything with WSS, but the first thing we're going to check is if not thread ID, right? We're going to just return thread ID. And actually what we could do is we could just make sure that we hook up this as well. So if you're doing anything other than just logging, you may want to actually handle that. You could break this out into a separate function as well, just so you're not repeating code. But for time's sake, I'm just going to go ahead and copy this for now. Or you may want to do something totally different here, right? So you may want to actually log that a thread ID didn't exist, and kind of make your server know that you need to handle an additional edge case because clearly you're not handling it correctly. So we have, if not thread ID now, we're just going to essentially pass in, or we're going to hook up that close function. And then we also want to now grab our threads, right? So we want to say threads equals clients, and it's going to be clients.threads. And then we can say if not threads thread ID, then what we're going to do is we're going to say that threads thread ID equals an array with WS as our first item in the array, right? Or actually our only item in the array. Otherwise, we're going to assume that threads thread ID is already an array. So we're going to push WS to the end of it. All right. So again, we're kind of guaranteeing that threads thread ID exists now, because if it doesn't exist, we're turning it into an array. You could actually be even more exact, and you could like import something like Lodash, and you could just check, make sure that this is actually an array and not just do the not operator here. Well, don't do that. But you could actually make sure that this is an array, right? If not is array, threads thread ID, then you just set it to an array, right? So we're guaranteeing in this particular, not in this particular case, but if you were checking if is array, you'd be guaranteeing it's an array and not just some random value that it was set. But in our case, we're only setting this here. This is the only place we're ever setting threads thread ID. And so it can't really ever be anything other than array. If you're working on a big project with a bunch of people, it may be better to use, some kind of helper functions where you're actually checking, making sure this is an array. But in our particular case, it's a single file. We're only setting it in one place. And so we can actually guarantee now that threads thread ID will be an array by the time we get here. So what we can do is we can just say, instead of WSS.clients, we're just saying threads thread ID for each client. And we're now sending the message only to those clients, right? So that should basically handle that particular case. Now, the only thing we want to do is we want to make sure that we kind of clean up after ourselves. So we can say const IDX equals threads thread ID dot index of, it's going to be WS, right? So we're closing this connection. We want to make sure that we remove it from the object. So we say if IDX is greater than or equal to 0. All right, then we can actually splice this guy. So threads thread ID dot splice. It's going to be IDX, and we're only deleting one item. And the last thing we want to do is we actually want to clean up the array itself. So if threads thread ID dot length equals 0, then what we know is in particular, there's nobody else listening on this thread, right? So we want to delete that array. So we want to say delete threads thread ID. And in that case, what you do is you don't get this object growing forever, right? So you can see that this in particular, even if you had dead threads that were never going to be used again, or you had deleted threads, this would still kind of continue to go on forever, and you wouldn't be actually ever removing those items. So the other thing that you can actually do, so you're actually terminating that. So no, you're good. So you're handled here because you're terminating that client, which is going to call the close function, which is going to remove it from that object. So no matter what, when that socket closes, we're removing it from this object. And when there's no more objects or no more sockets open in that particular thread, we're deleting that array from the thread map here. So that should handle that accordingly. And that handles, basically all the cleanup that we need to do for that particular thread, right? Or that particular functionality of threads. All right, so the last thing that we need to do is we actually need to use those functions, right? So what we can do is we can actually just basically say up here, we can say if not request.url, we'll just send all. And that's going to pass in WS and WSS. Else what we're going to do is we're going to actually parse request.url. So we can grab another IDX here, which is going to be request.url.index of, not includes, index of, this quotation mark. So we're basically going to be trying to pull off our query parameters here. So URI equals, IDX greater than or equal to 0. It's going to be request.url.slice 0 IDX. Otherwise, it's just the full request.url. And then we're going to grab our paths, which is going to be URI.split. And we're splitting on that /. And what we really need to do is we need to filter this because we don't necessarily know if our URL is going to come back as something like, thread/thread ID. And then particular, maybe like another, if we had the query parameters in there, it could be another /, and then AT equals, and then, our token. So if that's the case, right, if this is what we got, then if we remove the query parameter here, and then we split here, what we're actually going to do is we're going to get an array. Well, hold on. Let's just say we're going to get an array, and it's going to be empty string, and then it's going to be thread, and then it's going to be, your thread ID, right? Whatever that is. And then our last argument is going to also be empty string, right? And so we don't want these empties in there. And we could, in this case, remove the first and the last item and only grab the middle two. But we may get a request.url that's like this, right? So we want to be able to handle a request.url that's like this in case, the package updates and for whatever reason they stop including the first /. Who knows what's going to happen? So you want to make sure your code is bulletproof, right? And so all we really want to do is we want to filter, and we want to say, P return not P. And that's going to filter out, all of the items in the array that are essentially empty. And that should fix that issue there, right? So we now know that this pass array is going to contain all values. And so we can now just do our switch on paths 0. We know that paths is going to be an array. So if this is undefined, it should fall into our default case. So in our case, we're going to say case thread, send thread, and we're going to pass in WS and paths 1. All right, break. Otherwise, we want to do the default case, which is send all, and we're going to pass in WS and WSS, break. All right, so that should basically handle all of the cases we need. This is checking to make sure, if thread ID exists. So, that's going to be covered, and everything should be good then on our server. So we basically have everything set here. So let's go ahead and kind of pop open our index.html and test this thing out. So we need to kind of write a quick little test. And the way that we're going to do this is we're actually going to kind of replicate this input block here. And instead of send message, we're going to be opening not a token connection, but a thread connection. Now we're still going to be using our token because we don't want to have to log in. I mean, we could log in, but it's not a big deal. We're just going to go ahead and open the thread connection with our token. And we're going to say WS, thread open, and then WS thread input is going to be our input here. And typically in an application, you're not going to be, looking up a thread ID from a user, specified input. So this would typically be done, grabbing the thread ID from a database and then just opening the connection without the user ever knowing it with a particular thread path or thread ID path. And so in our particular case, it's going to be a little bit different, but we're going to kind of mimic what it would be like, or at least mimic the functions to be a little bit more like what you would do in an actual application. So disregard this. This is kind of just for testing purposes, right? And just showing you an example of how this is going to work. But let's go ahead. This is all we really need. We only really need this input block here. And we're going to kind of open up our app.ts. And what we can do with this is we can just kind of, let's go ahead and copy this one. So this is going to be, WS thread open. Got to make sure we change those values. And then we're going to have our WS thread input, which is going to have that ID, right? So we have our button and we have our input now. So let's go ahead and what do we need to do? We need to change the init connection here, right? So the init connection is basically going to just take in an additional argument, which is going to be our thread, which is going to be a string. And essentially what we're going to be doing is we're going to be checking right here, right? So we're going to say if not thread, then it's going to be empty. Otherwise, we're going to have essentially a /thread/ it's going to be thread. So we could make this thread ID to make it a little more explicit, but we'll just leave it as is. Well, let's go ahead and just do that. So we'll say thread ID, not thread ID, pass in thread ID. Otherwise, we have an empty string with just the TK, the token. And so the only other thing that I would like to do is on open and close, I want to make sure that we're showing that we're opening it up on a particular thread. So we can do something similar if not thread ID, empty string. Otherwise, we're going to say, for thread ID. All right, and so we can actually just copy this entire thing for the closed as well. And there we go. So we're going to actually show if WebSocket connection is established for a thread ID or if it's established globally. And then we need to just make sure that we hook this up. So let's go ahead and copy this and say WS thread open to add event listener. And we're going to actually need a function now. And typically, the way that this is actually defined, it's returning a function because we had it, essentially returning the function here and handling the click event. And so I'm going to leave it like this, right? We could make this a Boolean and then just parse our, our input value in this function. But I'd rather leave this function because this is a little bit more realistic about how your init connection would actually look in an actual application. And since we're kind of doing some shenanigans with the thread ID anyway, grabbing it from a user-defined input, I want to handle all that in our event listener here. So it's going to cause a little bit of a wonky experience on this init connection, which you'll see in a second. But don't worry about it too much. It's not a big deal. So I'm pretty sure you guys are going to understand what's going on here. So we're just going to say that we're actually going to grab the WS thread input.value. Right? And then we want to say, if not thread ID here, then we're going to just show a message and we're going to say, please provide a thread ID, right? And we can actually make sure that we know what the heck this is here. So we can say, thread ID is a placeholder, just so we actually know what's going on. And then this one is going to be our type message here placeholder. All right, that's not really important. That's just more for aesthetics, just so we don't get confused, just so I don't get confused. All right, and then sort of say, if not thread ID, we're gonna show the message, please provide a thread ID, and then we're gonna return. And then what we wanna do is we actually want to init the connection with thread ID, right? But this returns a function, so we actually have to call the function. So this is kind of what I was talking about. So we basically have this init connection that we're passing the thread ID to. This function returns a function, so we need to call the function immediately because up here, the function is actually being called by the click event, right? So last thing we want to do is, thread input dot value equals empty string. So we're just clearing that value. And this should be everything. So hopefully, if I didn't mess anything up, this might actually work. So let's cross our fingers. npm run dev. See if we get any errors. 0 errors. I love it. I love it when a plan comes together. Let's pop open a web browser, and we're gonna pull open localhost. All right. So we have. Whoa! Not that small. We're not mobile friendly right now. All right. So we have our test here. We can open a token connection. We did all this in the last authentication and authorization video. So now we're really gonna be dealing with this thread ID and the messaging here, right? So we wanna make sure that if we pop open, multiple windows here, let's pop open 4 windows. All right, and let's see, no, we're just gonna jump between let's see. It would be kind of cool to just kind of shrink this a little bit. Let's see if I can do that. Let's see if I can shrink this up. We're gonna close this, and we're gonna shrink this. Let's see if I can do this. Just pull this out. All right, let's shrink it a little bit more. All right. This is probably about as good as it's going to get. Let's see. All right, so we have our 4 windows open here. And what we really want to do is we're going to kind of open up threads on each one. So let's open the first one, open thread connection for ID 1. For the second, let's do 2. For the third, let's do 1 again. And then for this one, we're going to do 2. So theoretically, we should have 2 of these sessions open in thread ID 1 or thread 1, and then 2 of them open in thread 2, right? So if we send a message here in thread 2, all right, awesome. We sent hello, we got it back in the thread that we sent it from, and we also got it back in this second one here, which we did establish was, thread ID 2, right? So we have both of these sent, and we can see that in 1 and 3, we got nothing. But if we say, hello thread 1, send message, we can see that we did receive it in both of these. We did not receive it in these here, right? So looks pretty awesome. We are good to go. Now, if we did go ahead and send something to the regular thread, all of them would actually receive this. So we need to remember that as well. So for instance, if we were to close a connection, or if we were to open up an additional one here, right? And we just want to open a token connection now. If we type the message, hello world, this should go to all of our clients. So the rooms are not going to separate us from essentially sending to everyone. So we need to make sure that we know that. And most of the time, you should always be separating out any type of, clients, because sending to everybody would be something that maybe only something like a super admin could do in particular, right? So if we send this message, you'll see that all of our people connected received the hello world, and we had no actual separation or isolation at all. All right, so I hope you guys enjoyed that. Again, like I said, that was pretty much our last video in our intermediate WebSocket tutorial series that we're going to be doing. You can pretty much take these videos and build whatever you really need to build from a WebSocket server perspective. The only other thing that we probably could touch on would be a little bit more advanced, but it would be kind of scaling out your WebSocket server to have more than one instance, and then creating a level where you actually have a master controlling the slaves and having like a them all talking to one another, right? So you'd actually have to keep parity between all your servers with your connections. And so that's a little bit beyond the scope of our kind of like intermediate tutorials here. So we may go into do an advanced one down the road, but for right now, we're going to kind of chill with the WebSocket tutorials. We're going to go and create some different content. So make sure that you subscribe to our channel. We have a ton of stuff in the works, some really good stuff. And if you have any particular requests or you have any comments about our current videos, drop them in the comment section below. We love to hear from you. And honestly, we really do take all of your feedback to heart. We love you guys. We want you to stick around. We want you guys to enjoy what we put out. And, we hope to see you back soon. Get out of here.